All right. So again, we're back into chapter 12. Last time, what we did is we stated the reason I started with this slide. I just want to give you a little bit of a review before I know that we reached slide 45 last time, but I want to start from here so you know, as a quick review, what we are doing. This chapter about stoichiometry, which is the chemical calculations that we do whenever we have a chemical reactions on determining the quantities of material needed and the material that are produced. So with this general reaction, that is reactant G is going to produce a product B, W, and the A and B are the coefficient. This is a balanced equation. If that is the case, then regardless of the quantity of G that is provided, it could be particles, could be grams, it could be volume, but we can convert that into, or we have to actually convert that into moles of G in order to reach to the product. So we using the Avogadro's number, we are using the molar mass or the molar volume under STP in order to change the quantities into moles. You cannot calculate the other side of the reaction or within the same side except using the mole ratios. So you need to change anything to mole into the moles of G, and then you go to the moles of W through the mole ratio, which is extracted from conversion factor that is extracted from the chemical equation, the balanced chemical equation. And then after that, once you get into the moles of W, you have the, well, as a matter of fact, you don't have the freedom. You will follow what the question is asking you. If the question is asking for number of particles, then you have to do change that into number of particles using the Avogadro's relationship. If the question is asking you for mass, you use the molar mass. And if it's asking you for liters or volume, then you have to use the molar mass. And we have to assume that we have an STP conditions. Okay, so based on that, that's the way we solved this example over here last time, but I'm willing to go over it again, which is how many molecules of oxygen are produced. So it's asking you about the molecules over here. That is what is needed. Molecules of oxygen needed if we have 29.2 grams of water. So what kind of calculation is this? I mean, is it mass to mass? Is it volume to volume? Is it what? Can anybody tell me what kind of calculation is this? We call it. Hello? Mass to what? Mass to mole? لا, that is wrong, Faisal. It's not mass to mole. Mass to molecules? Mass to molecules? That is true, but it's better to call it mass to particles. يعني عشان to be using the same terminology, we call it mass to particles. That is true. طيب يا جماعة رجعنا نفس القصة، هو عبد الله المطيري وفيصل ونور ويمكن يطلع لي كمان واحد، بس where are the others يعني anyway أغلبكم قاعد بدرس فيزيكس يعني بتلاقي.
دكتور أنا معاك بس ما عرفت الإجابة الصراحة.
مين أنت طيب للأول؟
محمد مصعب.
محمد مصعب.
بس
ما عرفت الإجابة يا محمد مصعب؟ ليش ما عرفتش الإجابة؟
مو ما عرفتها، أنا كنت ملخبط يعني.
طيب خلينا نرجع كمان مرة هنا. هذا that's what we said. أنا معطيك جرامز، أوكي، هاي الجرامز، وفي الآخر طالب منك molecules. كل اللي كان بدي إياه for anybody to say mass to molecules or mass to particles. That's what I wanted. Anyway, طيب هذا السؤال إحنا حليناه last time. So what we need to do is to convert the grams into moles and then take the moles into moles of water into moles of oxygen, and then after that the moles of oxygen back into molecules using the the relationship. Okay, Abdullah Al-Mtairi, are you with us? Okay, so the way it works is that we have grams of water that is converted into moles of water, then into moles of that. To go from here to here, we know we need the molar mass ratio. To go from here to here, we need the mole ratio, which is from the chemical equation. To go from here to there, we need the Avogadro's relationship, which is 1 mole contains 6.02 times 10 to the 23 number of molecules. Okay, so for that reason, it is it's going to be like this: grams into moles, moles into moles, and then back into molecules, and this is going to be your answer. Okay, taking more examples. This one is good because it is had some new ideas about the using the volume. So nitrogen monoxide and oxygen gas combine to form the brown gas nitrogen dioxide, which contributes to the photochemical smog. Regardless of this, how many liters of nitrogen dioxide are produced when we have 34 liters of oxygen reacts with an excess of nitrogen monoxide? So the question is telling you that we have 34 liters of this, and this is in excess, so it's not needed in the calculation. That's what it means. And we need to know how many liters of nitrogen oxide we produce, assuming that we are operating under STP. So what kind of calculation is this? يا محمد مصعب مدامك المرة اللي فاتت ما عرفتش. What is it now? Is it mass to mass? Is it mass to molecules? Or is it what? We have
mass to molecules, sir.
برضو mass to molecules. هذا السؤال الأولاني. هذا السؤال is different. Let's read it again يا محمد.
يلا.
اقرأ السؤال أنت مش أنا. How many liters of nitrogen dioxide? How many liters? مش قايل لك how many molecules? How many liters are produced when 34 liters also? ما قالكش grams of oxygen. So we have liters to liters. That is volume to volume calculation. Okay?
Yes.
ماشي. So this is volume to volume. What we need to do to take the volume of oxygen into moles of oxygen. صح? How we do that? Using the relation which is under STP, we have 22.4 liters per mole. صح? طيب. Once we get into the moles of oxygen, we can take it directly to the moles of NO2 using the mole ratio, which is 1 to 2, right? Is it 1 to 2 or 2 to 1? يعني we multiply by 1 over 2 or we multiply by 2 over 1? We multiply according to Hadil by 2 over 1. That is true, because what we need is the moles of nitrogen oxide. So it is 2 to 1 and we multiply by 2 over 1. طيب, once we get the moles of nitrogen oxide, mole ratio from where? Well, هذا فيصل رجع لورا بيجي 20 درجة. كيف mole ratio from where؟ كم من مرة قلنا لك المول ريشيو منين بنطلعه يا فيصل القادري؟ المول ريشيو where we get it from the equation. ولسه في علامة سؤال. واو، إذا هذا الشاطر بقول هيك. أكيد من الإكويجن يا فيصل، يعني يمكن عقلك في الفيزيكس أنت، بس anyways خلينا نورجيك الإجابة. Okay, so this is liters into volume. And then this is the mole ratio يا فيصل. شفت؟ 2 moles of NO2 over 1 mole of oxygen. That is from the chemical equation. And then we multiply it again by 22.4 liters to take it back into liters. طيب, في حدا بيلاحظ شيء على هذا equation that we can reduce? In the case of, and that is only in the case of volume to volume calculations, since any mole of any gas can occupy 22.4 liters, maybe we don't need to go through the moles and then back into moles. We can use the volume ratio. يعني إذا بتلاحظ إنه هاي وهاي they are repeated، يعني هذول they will cancel with each other. فإحنا we could have done 34 liters times 2 moles, 2/1 ratio, and then get 68. Okay, so sometimes we can eliminate one of the steps if only if we have a volume to volume calculations, because going into moles and then back into liters will be using the same equation, since the molar volume, and that is 22.4 liter, is true for any gas at any STP. Okay, so that's why we can eliminate it. عشان أفهمكم شو المطلوب, let's take another example, which is this one. Let's read it very carefully. Assuming STP, مفهوم ليش why we saying assuming STP. We say that in order to tell you that yes, you can use the 22.4 liter per mole relationship. Okay, هاي معنات ال STP. Whenever you see assuming or operating under or whatever in the reaction, he is telling you, okay, you can use this relationship, which is 1 mole over 22.4 liter or 22.4 liter. شو التمبرتشر بعدين معك يا فيصل اليوم انت؟ why are you distracting us like this؟ شو دخل التمبرتشر في الموضوع؟ 22.4 لتر and temperature؟ ايش اللي عمري في حياتي ما سمعت فيك شغله. STP standard temperature and pressure، فهمنا خلصنا من الموضوع هذا. when we say STP يعني بنقصد ال STP. but what is the meaning of this? It means 22.4 liter volume per 1 mole. ما ترجعناش تلخبط الناس بيظلك temperature ومش temperature. اوكي طيب، قطع حبل افكارنا فيصل as usual. Assuming STP يعني يا فيصل and the others, it means use the 22.4 liter relationship. طيب, the question is how many milliliters of oxygen, هذا اللي بسأل عنه، mLs of oxygen are needed. بدنا نشوف قديش نحتاج oxygen to produce 20.4 milliliters of SO2. What we need to do إذا بدنا تتبع كل الخطوات الصحيحة يا عبد الله, it is volume to volume, that is true. But what we need to do is first to change the milliliters into liters. لأنه إحنا ما بنعرفش إنه ال STP بتقول 1 mole per 22.4 liters. إذا نحول المليليترز لليترز، وبعدين الليترز into moles، وبعدين المولز back into moles، وبعدين المولز back into liters، بعدين الليترز back into milliliters. بس هذه it's a long procedure. أنا what I said in the previous example is that whenever we have volume to volume calculation يا نور الجندلي, then in that case we don't need to go through the whole procedure, but we can take the volume to volume directly using the ratio from the chemical equation. وهذا الكلام I proved it by this one over here. See, in this one here we noticed that we could have gone from 34 to 68 by using this ratio without these two. صح? And that is only in the case of volume to volume calculation. Okay, مظبوط كلامك يا نورة. If we want to convert it into that, we need to well, what you did is not correct. 20.4 times 22 كيف بدي يصير هيك يعني؟ ضربتي milliliters في liters على 1 مول. هل هذا كلام صحيح؟ No. If you want to convert it, it should be the opposite. anyways أنا قاعد بقول إنه we don't have to do that. So all what we need to do is the following here. See, you take the 20.4 milliliters of the product multiplied by 1 milliliter of 2. من وين أجى هذا؟ من الإكويجن نفسها. هاي الإكويجن is if we have 1 molecule, it will produce 2 molecules. If we have 1 milliliter, it will produce 2 milliliters. And this can only be in the case of volume. ما نقدرش نقول 1 جرام produce 1 جرام طبعا، هذا معروف، ولا حتى anything else. But as far as the volume is concerned, yes, we can use it. So we can minimize the step. بدكش to minimize the step, بدكش to confuse yourself, do the whole procedure. If you want to do the whole procedure, أولا you have to take the 20 milliliters 20.4 milliliters. عشان تحولها لليتر شو بدك تسوي؟ بدك تضربها في 1 لتر over 1000 milliliters، هيك صارت بالليتر. بعدين تضربها في 1 مول over 22.4 liters عشان تحولها لمولز. بعدين تضربها في 1 mole of O2 divided by 2 moles of SO3 عشان تروح to the moles of the the oxygen. Then you multiply it by 22.4 liters divided by 1 mole of oxygen. Then you multiply it by 1000 over 1 liter to take it back into milliliters. You will get to the same answer, which is 10.2 milliliters. يا اما بتطول الموضوع كله يا اما بتخليه صغير، بس that is only in the case of volume to volume calculations. Is that clear?
Doctor?
Yes.
Could you repeat the calculation, please?
When we have, كمان مرة يا محمد, when we have volume to volume calculations, we don't have to go through the whole process. We can use the ratio from the equation directly. And that is for a simple reason, because any mole, what is Avogadro's hypothesis بتقول under STP any mole of any gas will occupy 22.4 liters. فبغض النظر هو oxygen ولا sulfur oxide, it will occupy the same volume. So I can use the ratio from the equation in order to determine that. So the ratio here is 1 milliliters of oxygen will produce 2 milliliters of sulfur because it is 1 to 2 moles. That's what I said. فعشان هيك تختصر الموضوع, it will be تاخذ ال 20.4 milliliters of SO3, you multiply it by 1 over 2, a ratio, milliliters to milliliters, and then you get into the answer, which is half of that. أصلا أنت with your eyes you can do that, بس احنا we don't recommend this. If you have produced 20.4 milliliters, أكيد you need half of them لأن the ratio between them is 1 to 2. واضح يا محمد؟
Yes, doctor.
Okay. طيب. Let's take this example. الحين هذا example, I want somebody to help me with that, which is, let's read it first. Methane burns in air by the following reaction. وانتم بتعرفوا انه any hydrocarbon في carbon hydrogen molecules or compounds or whatever you want to call it react with oxygen in a combustion reaction, they will always produce carbon dioxide and water. كويس؟ السؤال is, what volume of water vapor is produced at STP by burning 501 grams of methane? هلا يا محمد مصعب تقدر تقول لي what type of calculation is this? Is it mass to mass? Is it moles to moles? Is it شو هالكالكوليشن هاي؟ اقرأ السؤال كمان مرة وجاوبني عشان نشوف انك
طبعا هو مو فوليوم تو فوليوم دكتور.
ها؟
هو مو فوليوم للفوليوم.
اكيد مش فوليوم فوليوم ولا ايش؟
ولا مولكيولز، فاتوقع دكتور
لا الشغله مش هيك على فكره. الشغله مش يعني eliminate things وبعدين ترجع، لا 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 يا رجل العمليه سهله. هو بقول لك انه في، خلينا نكتب لك اياهم، في 501 grams of this guy وبسألك how many liters of this. بدها شطاره هاي يا محمد. شو الجرامز هذه؟ شو بنسميها؟ ماس.
يس.
وهذا شو بنسميه؟ الليترز.
هذا فوليوم.
طيب ماس تو فوليوم كالكوليشن، في اسهل من هيك؟ بدل ما تقعد تقول هي اكيد مش فوليوم تو فوليوم ولازم تكون فوليوم تو فوليوم عشان تليمينيت. شغله بسيطه. شو اللي معطينك اياه وشو اللي طالبينه؟ بتقول معطيني جرامز وطالب ليترز، اذا this is mass to volume calculations بس. That's all what you need to do. طيب How are we going to do it? Then that's the question. We're going to convert, first of all, طبعا لما يكون عندنا mass to volume calculation معنى ذلك انه احنا we need to take the mass into moles. ما عندنا خيار هنا، مش زي الفوليوم ما عندنا خيار انه احنا skip some steps. We need to take the mass into moles using the molar mass of methane relationship. صح؟ يعني نضرب ال 501 جرام times what? Times 1 over 16. منين جبنا ال 16؟ من ال molar mass of methane. طيب, this will give us the moles of methane gas. Then we take the moles of methane gas into how many moles of water produced. So that will be multiplied by 2 over 1 ولا 1 over 2? 2 over 1. Very good, ya Hadid. Because we multiply the moles of methane that we have times 2 moles of water divided by 1 mole of methane. This is from the chemical equation. What we get is, now after we did this, we get the moles of water produced. But is this what I need? No, the question is asking about the volume of water vapor. So I have to multiply this by 22.4 liter per mole. So this is what you need to do. I'll first step for conversion of grams into moles. High second step, which is converting moles to moles according to the mole ratio from the chemical equation. هذا اللي كنت بقول عنه 2 over 1 or 1 over 2. Once we are on the other side, which is up to here, كل هذا الكالكوليشن تعطيك المولز of H2O. صح؟ Then you multiply it by this relationship under STP. That will give you the liters of H2O produced. Okay? Is that clear? All right. That's it. That's it with the section number 12.2. Now we're going to move to section 12.3. But before we do that, I want to do a little bit of an introduction to that. I want to remind you of a question over here, which we went through, and that is, yes, here. Why did he say here in this question that how many liters of nitrogen dioxide are produced when 34 liters of this reacting with excess of nitrogen? هو قالنا إنه excess of nitrogen monoxide. فit is possible إنه يكون واحد فيهم in excess. لما يكون في عندك 2 reactants, okay, if you have a reaction with 2 reactants, one of them will be consumed first, أكيد. The one which will be consumed first is the one that we need to determine as, we call it, limiting reagent. That's what we are discussing in the, let me just take you to the slides first. Okay. Here we go. This is 12.3, which is called the limiting reagent and percent yield. شو يعني limiting reagent? It is the reagent that will be consumed first in a chemical reaction. عندك A reacts with B to produce C. You have certain quantity of A and certain quantity of B. أكيد one of them will be consumed first. The one which will consume first is the one which will determine how much C we can produce. صح? How the A and B will react according to the ratios. لو كان في small a or small b over here or small c, the ratio between A and B is a small a to small b. So according to the ratio, the one which consume first is called the limiting reagent. طيب والثاني, the one that is not a limiting reagent, that is not completely utilized in the reaction, we call it the one which is in excess. So we are talking here about reactions that have more than one ingredient, يعني combination, single replacement, double replacement, combustion, something like that. Okay, these kind بس مش decomposition لأنه decomposition is made from single reactant into one product. كيف single reactant هو بس بيخلص صح ولا لا؟ But when we have two reactants or two things that or more that are reacting with each other, one of them will be consumed first. But the one which will consumed first is the one which will stop the reaction. And that's why we call it limiting reagent, the one that will limit the reaction from being to continue. So this is the first topic that we're going to discuss. The second one is most likely we're not going to do it today, which is the percent yield. The percent yield يعني your efficiency or your reactions efficiency. But you can apply it on you. Let's say you got 90% in chemistry 1. شو يعني 90% when you get, this is your achievement, this is your efficiency. You got 90% of the scores that we're given a chance to. احنا معطينك chance to get 100%. حاطين لك 100 علامة. We have 100 marks that is assigned to this course. Whatever you get is your efficiency. That's what the meaning of a percent yield. لما بنعمل reaction, okay, we should produce 100% of the product. But عمليا ما بيكون هذا الكلام صحيح. Some of it will be lost here and there, and that's why we need to determine what a percent yield. Anyways, let's leave this topic for next time. But for now, let's focus on the limiting reagent. تخيل حالك يا محمد مصعب تخرجت وما لقيت الشغل واشتغلت نجار. كويس؟ صرت كاربنتر وعطناك الطاولة هاي مشان تسويها. منيح؟ وعندك الكاربنتر هذا عنده 2 تيبل توبس. بلاش الطاولة هاي سيبها، أنا بدي أرسم لك طاولة ثانية. هاي الطاولة هذا الراس تبعها وهي الرجلين 1 2 3 4. أوكي؟ يا محمد مصعب, if we give you 2 table tops.
Yes.
و 7 legs. How many tables you can make?
1.
ليش؟ لأنه ما عندك enough legs to do the 2. صح؟ إذن ولما تسوي ال1 table شو بظل عندك؟ The one that stop you from finishing this is the legs. Those are the one which limits you. مش ال table tops. إذن بنقول في الحالة هذه the legs of the table is the limiting reagent. That's the one which stop you from doing that. While the table tops are in excess. هذا
You mean stopping me doing another table? Stopping me from doing another table?
Yeah, it will stop you from doing another table. خليني أعطيك مثال ثاني. افرض يا محمد إنك اشتغلت في محل فلافل. كويس فلافل على الصبح. منيح؟
أيوه.
كل سندويشة فلافل كم حبة فلافل المطاعم بحطوا فيها؟
4.
لا أنا بدي أعطيك 3 بدناش 4. أوكي هاي 3 حبات فلافل وشوية حمص وشوية سلطة. منيح؟ كويس جايز؟ طيب. الآن إحنا أعطيناك 4 بريد. كويس؟ وأعطيناك يا محمد 15 حبة فلافل. 15 pieces. ورطل سلطة. وقلنا لك سوي لنا سندويشات يا محمد. How many sandwiches you can make? The maximum.
أول وحدة إيش 4 وشو؟
4 خبز.
4 خبز أيوه.
كم سندويش بتقدر تعمل؟ 4 خبزات و15 حبة فلافل و2 كيلو سلطة.
4.
ليش؟ لأنه ما عندك غير 4 خبزات. This الخبز is the one which will stop you from doing more falafel sandwiches, right?
Yes.
وضحت الصورة تبعت limiting reagent now؟
وضحت يا دكتور.
خلاص الحين نسوي تاكو بعد شوي. هاي تاكو. Okay. التاكو as you know is made from the tacos اللي هو الشيلز هذه وبنحط فيها تشيز وميت ولاتس وصوص. لو كان عندك ترك من هذول وعندك 2 tacos only, the maximum you can do is 2 tacos بس. لأنه وين بدك تحطهم في إيدك ما بنفع. لازم تحطهم في tacos. فإذا كان عندك كل هذول الانجريدينتس and only 2 tacos, then you can make a total of 2 بس. لأنه the number of shells, the taco shells that you have is only 2. فthis is زي موضوع الخبز والفلافل صح؟
So the limiting regions is the tacos, right?
Yes, that is true. طيب خلينا شوي الآن دشنا من الأكل ونروح على الكيمستري. في الكيمستري ما عندنا تاكوز ولا فلافل ولا خبز ولا بطيخ. في عندنا reagents, that the reactants. Okay, so we need to see which one of the reactants, if we have more than one, that will limit the reaction, that will stop the reaction because it is consumed. ما ضلش منها شيء. It is over. And the one which is in excess. Okay, that is exactly what the limiting reagent is about. Let's go back to making ammonia هالمرة. It's not going to make falafel or something else. We're going to make ammonia from nitrogen and hydrogen. According to the balanced chemical equation that is in front of you over here, 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. Which means that if we, this is what I read here, اللي هو المicroscopic one. طيب, if I want to do it by molecules, here it's the same thing. 1 molecule of nitrogen reacts with 3 molecules of hydrogen to produce 2 molecules of ammonia. طيب, تخيل, imagine that I gave you 3 molecules of hydrogen and 2 molecules of nitrogen. Before the reaction, we have 0 molecules of that. عندنا 3 من هاي و2 من هاي. Let's start the reaction then. After the reaction, they will react according to the chemical equation. 3 of this will react with 1 of that to produce 2 moles of that. شو بضل عندنا extra? 1 molecule of nitrogen. So in that case, who stopped you from making more nitrogen? It is the
hydrogen.
The hydrogen, exactly. So hydrogen in this case is called the limiting reagent, and nitrogen is the one which is in excess. Okay, so hydrogen is your limiting reagent. بس مش كل مرة بنعطيك سؤال بدنا نرسم لك إياه زي هيك ونعطيك number of molecules والى آخره. No, we could give you any quantity. نرجع لموضوع ال quantities. We could give you particles, we could give you mass, we could give you moles, we could give you anything. And we ask you which one is the limiting reagent. عشان نفهم أكثر, let's take more examples. Okay, سيبك من التيبل هاي, خلصنا منها. هذا الزلم الشورتي اللي in front of you, he's saying that he wants to run a reaction of copper with sulfur to produce copper sulfide. حلو? Copper 1 sulfide. طيب, the question is, هاي الchemical equation in front of you, and the question is, if we have 80 grams of copper with 25 grams of sulfur, which one will be the limiting reagent يا محمد مصعب? Is it the sulfur or the copper?
ترى عادي تعيد بالله لأن كان في حد يناديني.
والله أنت قاعد في كلاس مش قاعد في كلاب. ليش حدا
معليش
يناديك؟
آسف.
ممنوع حدا يناديك. طيب, copper, 2 moles of copper reacts with 1 mole of sulfur to produce 1 mole of copper sulfide. The question is, if we have 80 grams of copper reacts with 25 grams of sulfur, which one of them is the limiting reagent? Which one will be consumed first? Sulfur or copper?
The limiting reagent is the sulfur, doctor.
طبعا في نورة قالت سلفر وانت بتقول السلفر ونورة جندلي وغادة وكلكم غلط.
ليش دكتور؟
أنا الحين بقول لك ليش. لأنه إحنا الرياكشن when I read it I did not say 2 grams of copper reacts with 1 gram of sulfur to produce 1 gram of that. ما مستحيل يكون هيك أصلا. It is 1 mole. فأنت ما بتقدر تحكم على الموضوع إلا إذا if you convert these grams into moles first. فإذا your answer is wrong. You cannot judge based on the quantities that is provided to you. You have to judge based on the number of moles available. Then, in order to answer such a question, which is what is the limiting reagent, we have to convert them into moles. خلينا let's do that. عشان نشوف وين الغلط يا محمد. هاي ال 80 grams we change it into moles. كيف حولناها بمولز؟ بالمول ريشيو تبع المولر mass, which is 1 mole of copper divided by 63.5 grams of copper. وهاي 63 جبناها من وين؟ من البيريودك تيبل. اوكي؟ طيب, طلع عندنا 1.26 moles of copper That's what I have. طيب والسلفر how many moles I have؟ 0.779 معناها كلام محمد صحيح. عندنا 0.779 moles of sulfur 1.26 moles of copper. معناها السلفر بخلص للأول. معناها السلفر هو فعلا limiting reagent. Is this true يا محمد؟
يس دكتور.
لا. وقعتك في الغلط كمان مرة. ليش؟ قول لي ليش طيب.
ليه؟
انت بدك تشوفني ليش مش انا.
طيب لان دكتور
ليش؟
برضه لسه ما طلع
ليش طلع هنا ليش؟ لانه 2 moles of copper needs 1 mole of sulfur. الشغله مش 1 to 1. لو كانوا بتفاعلوا 1 to 1 كان كلامك على عيني وراسي. يس هذا 1.26 وهذاك 0.779 then اكيد السلفر بخلص الاول will be consumed first. But that's not the case. So what I need to do is to use the mole ratio from the equation to decide. What I will do is take the 1.26 moles of copper, صح؟ هاي اللي طلعت معي, and multiply it by the ratio. الريشيو تبع مين؟ اللي هي العلاقة ما بين الكبر والسلفر, which is 1 mole of sulfur divided by 2 moles of copper. هاي منين جبتها أنا؟ من chemical equation, صح؟ شو الجواب بيطلع؟ 1.26 divided by 2, that is 0.663 moles of sulfur is needed. إذن طب أنا قديش عندي سلفر أصلاً؟ How much sulfur I have?
0.779.
وأنا I need 0.663.
Yes.
In order to consume all the 1.26 moles of copper, I need only 0.663 moles of sulfur. But I have 0.77, which is more than what I need. So which one is the limiting reagent? Which one will be consumed first? It is the copper, not the sulfur. Okay?
Yes.
This is what you do. Based on that, based on what we did over here, somebody might say, why did you use the copper? Why didn't you use the sulfur? Yes, ماشي. خليني to use the sulfur. بدل ما استعمل copper, I will say 0.779 اللي هو I have it of sulfur times 2 moles of copper divided by 1 mole of sulfur بيساوي 1.558 moles of copper needed. Even for me to consume all the 0.779 moles of sulfur, I need 1.55 moles of copper, which I don't have. معناها, again, this is indicating that the sulfur is the one which will remain in excess, and the copper is the one which will be consumed first. Okay? واضح؟
هي دكتور هي سهلة لكن it's a little bit confusing يعني.
مش confusing ولا شيء. What you need to do is to practice more.
Yes.
You need to practice more examples, and that's the way you should do it. First of all, let me just summarize by saying that أولاً, what is the meaning of limiting reagent? It is the one that is consumed first. This is number one. What is the meaning of the one which is in excess? It is the one that is not completely utilized or used in the chemical reaction. طيب, why we need to do this? شو الفائدة من إني أعرف which one is the limiting reagent? عشان أعرف how much product I will produce. You remember a table and falafel and tacos? Without knowing the limiting reagent, I won't be able to answer the question is how much tacos I can produce. كيف بدي أعرف لو ما كنتش عارف مين ال limiting reagent؟ صح؟ فلذلك it is important to do this question here in front of you, which is what is the maximum. هذا السؤال لحاله. نفرض السؤال بيجيك هيك في الامتحان, which is what is the maximum number of grams of copper sulfide, the grams of copper sulfide that can be produced. إذا كان عندي 80 grams of copper and 25 grams of sulfur. In order to answer this question, to find the grams, لازم to know which one is the limiting reagent, and that is the one I'm going to use. لأنه تعرفين إنه we have two conversion factors between أنا مش فاهم شو اللي بدك إياه to repeat يا نور. To repeat the whole concept ولا كمان مرة. limiting reagent is the one which is consumed first. اللي بيخلص يعني. excess is the one which is not completely utilized in a chemical reaction. Why we need to do that? In order to determine how much product we can produce. And look at this equation. In order to find how many moles of copper sulfide is produced, you can use sulfur or you can use copper. صح ولا لا؟ But if I use the sulfur in this case, الرقم اللي بيطلع معي هون بكون أكثر من اللازم لأني I used everything available, which is not true. So I need to use the limiting reagent. First of all, in order to calculate what is the maximum number of grams of this is produced, لازم أعرف which one is the limiting reagent. طبعا in our case here, we know that this is the limiting reagent. So I will use the 1.26 gram moles that I calculated in the previous question, and I multiply it by the mole ratio between this and that. هلا سيبك من السلفر. خلص sulfur is out of the question. يعني in other words, this is what I do. 1.26 multiplied by 1 mole of copper sulfide divided by 2 moles of copper. هذا mole ratio is coming from the equation. This will give me the number of moles of copper sulfide produced. Then I multiply it by the molar mass of copper sulfide, and that will give me 100 grams of copper sulfide will be produced in this case. This is the maximum number of grams that can be produced. Then the one that we use in the calculation is the one which is the limiting reagent. يعني لما يكون عندك A plus B to produce C moles of C, B moles of B, and A moles of A. وعطيناك the grams of this one or the grams of this one, وطلبنا منك how many grams of this one. Before you decide, you have to choose either A or B to be used in the calculation. Which one you use? The one which is the limiting reagent. ما بتقدر تستخدم the one in excess. لأنه إذا بتتذكر لو رجعنا لموضوع I want to take you back to this here. Yeah. لو أخذنا النيتروجين in that case بدنا نحسب 2 moles of nitrogen معناها بنطلع هنا 2 molecules of nitrogen. If you use it as the one which is the limiting reagent معناها هم علاقتهم 1 to 2 معناها بنطلع 4 molecules of ammonia, which is not true. We cannot produce 4 molecules of NH3. But if we use the hydrogen, yes, it is only 2. So that's why the limiting reagent it is very important. Okay, let me see if we have one more example here. This is one more example, and this is good because this will show you one other way of doing it, which is the rusting reaction. The rusting reaction means the reaction of, I want you to read the question and focus on it. طيب إذا في عنا a reaction which is iron with oxygen to produce iron hydroxide. I will do this quickly because we need to stop, but we will review it later on. So if we have 7 grams of this or 9 grams of that, وبسألك السؤال which one is the limiting reagent? مين بيكون limiting reagent? الiron which has 7 grams ولا الwater which has 9 grams? الايرون. شو عرفك انه الايرون يا هديل؟ عشانه 7 جرامز؟ لا ما بصير thinking. هذا ما بصير thinking. الجواب لازم يكون I don't know. لما اسالك سؤال اقول لك 7 grams of iron reacts with 9 grams of water. Which one is the limiting reagent? You're going to tell me at this time I don't know. I cannot use the grams. كمان مرة بقول we cannot use the grams. We have to convert it into moles and then use the ratio and see how much I need from the other side. In other words, this is what you need to do. Grams of iron into moles of iron. Then using the mole ratio will give you the moles of water. Multiply it by the number of grams of, or the molar mass of water. That will give you how many grams of water is needed. What you need is 2.26 grams of water to react with all the 7 grams of iron. طب أنا قديش عندي water? I have 9 grams. So which one is in excess in this case? That is the water. And which one is the limiting reagent? Is the iron, but not based on the 7 and 9, based on this calculation. Okay. Anyways, I wish that you guys can do more examples at home, and we'll meet with you, inshallah, on Thursday, and we will continue with this thing. Okay. I wish you the best. Huh?
Have a good day.
You too. Good luck with the physics exam today, and please be careful. Keep your first mask all the time, and inshallah we'll see you safe on Thursday. Yalla, take care. Bye.